Hello, Professor. I got a question about a chemistry topic we studied the other day in class.
Good thing you came to me, child. What can I help you with?
I do not understand the topic on the states of matter.
Do you know what matter is?
I know that matter is anything that occupies space and has mass.
That's right. Matter can be classified according to its state and its composition. State of matter is its physical form, and composition is what components make it up.
So then any substance is a matter?
That's right. Matter exists in three states: solid, liquid, gas. In solid form, the molecules or atoms in matter are packed close to each other in fixed locations. Although the atoms vibrate, they do not move past each other. A solid has a fixed volume and rigid shape. In liquid matter, atoms or molecules pack as closely as in a solid, but they are free to move relative to each other, giving liquids a fixed volume but not a fixed shape. Liquids assume the shape of their container. In gases, atoms or molecules have a lot of space between them and are free to move relative to one another, making gases compressible. They also assume the shape and volume of their container.
Well, this is easy. Is that all I need to know?
Chemistry would be easy if this was it. But unfortunately it is not that easy.
Well, what else is there to it?
Well, in the case of the solids, they can be two types: crystalline and amorphous. In crystalline solids, the atoms or molecules that compose them are arranged in a well-ordered three-dimensional array. And in amorphous, the atoms or molecules that compose them have no long-range order. The arrangement in a crystalline solid is called a crystalline lattice. The crystalline lattice of any solid is the nature's way of aggregating the particles to minimize their energy. It can be represented with a small collection of atoms, ions, or molecules called the unit cell. When the unit cell is repeated over and over, the entire lattice can be reproduced. Many different unit cells exists, but for our purposes we only learned about cubic unit cells, which are characterized by equal edge length and 90-degree angles at their corners. The fundamental types of crystalline solids are molecular solids, ionic solids, and atomic solids. Composite units of molecular solids are molecules, and they are held together by intermolecular forces. They have low to moderately low melting points. Ionic solids are composed of ions. They are held together by the Coulombic interactions that occur between the cations and anions that occupy the lattices in the crystal. Atomic solids are composed of individual atomic solids. Non-bonding atomic solids are held together by weak dispersion forces and have very low melting points. The examples are noble gases in their solid form. Metallic atomic solids are held together by metallic bonds and have varying melting points. Lastly, network covalent atomic solids are held together by covalent bonds and have high melting points. Some examples of these would be diamond, graphite, and silicon dioxide.
Okay, so now I have a better idea about the solid state of matter. But our liquids and gases also have special properties.
You need to be a better student and pay attention in class when we talk about these things. But since you are asking, I will tell you about those properties as well.
Okay, Professor, I am ready to listen.
Liquids exist as a pure substances or as solutions. Solutions are the most common. A solution is a homogeneous mixture of two or more substances. The majority component in solution is solvent and minority component is solute. In aqueous solutions, which are most important for our topic, water is the solvent and the solid, liquid, or gas is the solute. The solubility of a substance is known as the amount of the substance that will dissolve in a given amount of solvent. The solubility of one substance in another depends on the types of intermolecular forces that exist between the substances as well as within each substance. The solubility of most solids and water increases with increasing temperature, and the solubility of gases and liquids generally decreases with increasing temperature, but increases with increasing pressure.
Okay, I think I understand now. Thank you, Professor. From now on I will pay attention in your lecture class.
You're welcome, child. Hope that chemistry will not be hard for you in the future. Thank you for listening. See you later.